This conference will now be recorded.
Okay. All right. Well, hello, everyone, and thank you for joining us for this fourth webinar that we're having on soil moisture products. We are hearing more today about the UCLA Experimental Water Monitor as well as Climate Engine and the soil moisture components of those various products. So thank you to Dennis Lettenmeyer and Dan McAvoy for joining us today to give us an overview of those products. So if you've joined before, looking at the list, I believe pretty much everyone has joined previous calls. But just a reminder that, these webinars are meant to be sort of a deep dive into these various soil moisture products that we could use for monitoring in the Midwest. And the end goal is to learn more about these products and hopefully be able to identify some products that we, are best to use here in the Midwest that both best represent the conditions on the ground. So that's sort of where we're going moving forward. Before we jump into the presentations, we wanted just to do some brief introductions so that Dennis and Dan know who's on the call today. Feel free if you want to turn on your camera for your introductions, that would be great. If not, that's fine too. But I will go ahead and start off and then just call people off as I see you on the list. So my name is Molly Wolozin, and I am the Midwest DEWS coordinator with NIDIS, and I'm located in Champaign, Illinois. Chip, if you want to go next.
Hello, I'm Chip Zimmer. I'm with the Kentucky Division of Water.
Great.
And I do the drought monitoring for the state of Kentucky.
Perfect. And I'll just have the presenters also introduce yourselves now. If you want to go into more detail after, you can as well. But Dan?
Hi, everyone. Dan McAvoy. I am the regional climatologist at the Western Regional Climate Center and Desert Research Institute in Reno, Nevada.
Great. Dennis Lettenmeyer. Oops, Dennis. Dennis, we actually, I think you were muted. If you want to go ahead and really quick introduce yourself again.
Am I unmuted now?
You're unmuted now. Yep.
Okay, fine. I don't know where the mute is on this thing. In any event, yeah, I'm a professor of geography at UCLA. I was at University of Washington for many, many years. In fact, most of the work I'll talk about was done when I was at UCLA at UW prior to 2014. I'm a hydrologist. My main interest is modeling and prediction, quite a bit of it at large scales.
Great, thank you. The other Dennis Toddy.
How many times has that phrase been uttered in the history of humanity? The other Dennis. Dennis Toddy, Dennis Toddy, director of the USDA Midwest Climate Hub in Ames, Iowa. We're housed in USDA ARS.
Great. Glenn. Glenn, if you're speaking, I think you just unmuted.
Okay, am I there? I'm Glenn Kaler, University of Maine Cooperative Extension weather user.
Great, thank you. Ileana?
Hello, my name is Ileana Dobreva and I'm with the Ohio State University.
Marin?
Good morning. I'm Marin Stofflet, and I'm the regional hydrologist at the Central Region headquarters of the National Weather Service.
Great, glad you could join us. Marina?
All right. Good morning, everybody. I think most of you know I'm the program specialist at NIDIS, working on the National Coordinated Soil Moisture Monitoring Network.
Melissa, with that really nice MRCC little zip up that you have on.
Thank you. Hi, everyone. I'm Melissa Widhelm. I am with the Midwestern Regional Climate Center. I'm Associate Director and Regional Climatologist located here in West Lafayette, Indiana.
Great. And Beth, I'll have you go next.
Hi, I'm Beth Hall. I'm the Indiana State climatologist and director of the Midwestern Regional Climate Center at Purdue University in Indiana.
Trent.
Yeah, I'm Trent Ford, state climatologist in Illinois at the University of Illinois here, and do drought monitoring as well as quite a bit of research with soil moisture.
And Aaron Wilson.
Good morning, I'm Aaron Wilson. I'm at Ohio State University, joint appointment between the Bird Poll and Climate Research Center and OSU Extension. And I'm also with the State Climate Office of Ohio.
Wonderful. Did I miss anyone? Okay, great. Well, thanks again for joining us. And Marina, I am going to turn it over to you, and I will also start to make Dennis the presenter so we can get all that set up.
Okay, great. So thanks everybody for joining. As you know, this is our fourth in the series of soil moisture tool explorations. Again, as Molly mentioned, the point of this series was to give you all an opportunity to have a little closer look at some of these tools to see where their strengths and weaknesses are, or where their application might make sense, what kinds of soils, what kinds of regions of the country, et cetera. This is our fourth. So starting way back in December, we had, if I can bring up the list, just to remind us all, sport lists and crop chasma, then January Grace and the nationalsoilmoisture.com, February the CPC tools, and then today we're going to be looking at the UCLA experimental surface water monitor and the climate engine tools. And so this has sort of been an ongoing survey. With this last session today, I think we're going to be taking a pause after this and then coming together and kind of asking ourselves, what should we do next? Do we want deeper dives in any one of these, or are there other ways we want to, again, explore a little bit more closely how they might serve the purposes of those of you trying to help and make decisions in the Midwest? So we're going to start off now with the UCLA Surface Water Monitor, and Dennis, go ahead.
Okay, thank you, and thanks for inviting me. So first off, a little bit of apologies because I know when I was invited that this was about a group in the Midwest, and most of our group is in, or most of our work is in the West, although we do continental scale work as well. And I suspect that our products got the attention of people for the continental US maps. I'll try to go focus on those mostly. Just as a note then, when I moved from, I was at University of Washington for 39 years. In 2014, I moved to UCLA. So the title visual I had at when I was at University of Washington was a nice pristine mountain lake. When I moved to UCLA, somebody put this picture, which I think is Shasta Reservoir, 2014, of course, was the big drought. So I guess there's some message there. So the work that I'm going to talk about goes back to the early 2000s, and there's a paper in BAMS 2006, I guess, December 2006, Andy Wood and myself on a test bed for new seasonal hydrologic forecasting in the Western US. A lot of the work that's done here, and still the, presentation and so on, and the data sets go back to work that Andy Wood did. And we've been running this thing since like probably 2004, 2005 timeframe. But anyway, that paper describes some of it. The surface water monitor that I'm going to show, it's basically the initial condition for an ensemble forecast system that was described and it's actually 2006 paper. The important thing though, it's 1/2 degree spatial resolution across the conterminous US. There are 4 models I'll talk about originally. Originally, it was just the variable infiltration capacity model, which is something my group has used for many, many years. It's now 1/16 degree across the US. That's actually the inset there is the Western US, 1/16 degree. And you guys don't really care. We pull in station reports for surface for snow water equivalent across the West as well. The important thing is, and I don't know if my cursor shows, oh, maybe it does. The red thing, if you see that where it says current, That's actually what you're going to be seeing here is the initial state out of what was a forecast system. There's data that runs up from the historic past, and it actually goes back to 1920 up to the present date. And then there's some forecast stuff we're not going to be talking about today, but it's this red box that says initial state is what we're going to be talking about. So there are 4 land surface models. They're either hydrology models or land surface models that are used in numerical weather prediction or climate models. So the variable infiltration capacity model is ours. And I'm not going to talk about details of any of these models, except to say that the soil moisture that you see comes out of models. That's important. So there's ours, catchment, which is a NASA model, NOAA, which is NOAA's model. Oops, I'm sorry, with it's later been replaced by NOAA MP, but what you'll see, it's the old NOAA, and the Sacramento soil moisture accounting model, which goes way, way back, believe it or not, to before I was a grad student. That's how far, is still used for flood forecasting at most of the river forecast centers. And then we show a multi-model mean as well. So in order to get soil moisture, we're running a model, as I mentioned. We need forcings to the model. The forcings are daily precipitation and maximum and minimum temperatures from about 2,100 stations across the conterminous US that report daily. They're mostly, possibly all in the Cooperative Observer Network. We picked them because they have relatively long records, and I'll mention a little bit later on, we use soil moisture percentiles, and to get a percentile, you need to have it relative to some historic period, and we want a relatively long period. So there are many other data sets that have many more stations, up to like 10,000 and more, including some that we use. But 2,100 is the number of these things that have been around for a relatively long time. There's some derived variables that the models need, like downward solar and long wave radiation, vapor pressure deficits. Those come from algorithms indexed to, and apologies again for the typo, Tmax and Tmin. I'm not going to talk about those algorithms, but if anybody's interested, there's papers around to describe them. Surface wind comes from NCEP NCAR reanalysis, which is very coarse, but it is kept current in near real time. The stations and the model output that you get off our website for, say, soil moisture are updated to the previous day's conditions by 2 p.m. Pacific, and in theory. And usually it seems to happen that way. I check occasionally to see. So when I pulled some, there's a couple of visuals here that I showed that I pulled just an hour ago, and they're the 13th. So it is the 15th today at 2 p.m. today. They'll get updated to the 14th. Model output, the important thing, soil moisture, is total column soil moisture as the models see it to a depth of about 1 meter, which varies by model. Again, the output percentiles relative to this historic period goes back to about 1920. Many of these retrospective data sets use histories that go back more to the 1980s or so. There's arguments both ways. Ours is that we do have the 30s throughout in our data set, and there's actually a retrospective. So these models, in order to get the baseline, the percentiles relative to the models, are all run back to that 1920 date. And I'll show you, you can actually go look at the month, the soil moisture by month for the VIC model going back to 1920 or so online. There's a little tool that gets it. And again, we take stations reported on a given day. The retrospective, so we take all the stations that we can get that we're reporting basically as of yesterday, but we go back periodically and scrape up the ones that were late reporters so that the data set gets as many of them as possible. And in theory, there's a data set that goes up that's available, that goes along with this, that's available up through yesterday. People occasionally ask us for that. So if you go to the website, and the website is just hydro.ucla.edu, and there's a thing that pops up and it says drought monitors. If you go there and a little bit of fooling around, you can get a multi-model map. I started putting this together a week ago because I got the email and I thought, oh my God, the presentation's tomorrow. I forgot about it. And then I read the email and realized, no, it was really a week later. So I stopped until yesterday afternoon. That's why some of this stuff shows as the 6th of March. But you can see, not surprisingly, the 4 different models, and then in lower left is the multi-model mean. And they look, you know, if you stand back far enough, they look similar. We got this drought down in California and through the Southwest. We've got some feature in the lower Great Plains and so on. Some of the models thinks there's something going on in the Northwest. Mostly that's NOAA. The other models think not so much so. All of them kind of agree that Southern California has been pretty dry. So you do get some sense across the models of agreement and disagreement. And this is 1/2 degree. There's actually an averaging algorithm in there which kind of smears out so you don't see the sort of boxiness, but it is 1/2 degree, which is pretty coarse. And there I just put the drought monitor as of the 1st, and you know the drought monitor sees this bigger area of the West with the blotchiness in very broad context, something going on in the West, not so much elsewhere. Not sure why I put this one up. This is for VIC only. Probably we do pick up Mexican data as well. Mexican data is always problematic. But this should be, aside from Mexico, basically the same thing. It sort of shows the control panel there. So you can choose what's shown as soil moisture percentiles. You can also get snow water equivalent, which is of interest in the Midwest, of course, during the winter. You can get total moisture storage, which is soil moisture plus SWE, and you get percentiles in the same kind of maps. For both those. There's some other things that I'm not sure I would trust so much, which is cumulative model runoff and so on. I will say that the conterminous US output is run kind of on remote unattended. Other than adding some models, we haven't done much with it in a long time. We kind of check it to make sure that it makes sense, but there haven't been many new innovations in the conterminous US part of it. We do the same thing over the Western US. I thought I'd just throw this in. We're slowly upgrading models, higher spatial resolution, 1/16 degree in the West. We've gone from NOAA, old NOAA, to NOAA MP, which is the land scheme in the National Water Model, and we believe is a more credible hydrologically. This should be basically, I'm not sure why, total moisture here, which includes the snow in the West. Obviously, that's important. And the soil moisture, if you look carefully where you see the differences, it's going to be the same where there isn't snow or much snow. But if you look in the mountainous part, there is a difference because obviously the moisture gets stored in the winter in the snowpack, not in the soil column. You do get snow water equivalent out of this. I believe you can get this across the conterminous US at 1/2 degree as well. I would have to check. We do pull up the SWE observations, and again, we don't have active research going on with most of this. And I noticed when I pulled it up, there's supposed to be snow observations from the Canadian part of the Columbia River Basin, and they're not there. Periodically, what happens is somebody changes data formats or something in the system chokes. Yeah, thanks for putting the inset of the link there. I mentioned this, that this is, you know, if you're interested in what's gone on historically for the VIC model, and this has been sitting there for, I think it only goes through about early 2000s, but the retrospective for the VIC model for the conterminous US is there, and I can't remember exactly what the control, it says retrospective or something like that on one of the screens, but you can go in and put in month and year. I put in August 1934, and you can go see, and then you can flip through this one at a time if you want to look at the worst part of the 30s drought. You can also go in and put 2011-12 timeframe, and you actually see in the whole record, it's about the only period where there's drought covering essentially the entire conterminous U.S. So in summary, the surface water monitor has been around for at least 15 years. I don't have the exact date. Aside from adding models around 2010 or so, hasn't really changed very much. Most of our more recent effort, and that being since I've been at UCLA, has gone into higher resolution across the West. For the West, we're slowly adding more models. We have NOMP running, another model called SUMA is running, and we'll keep running it as long as it's convenient. But we don't really plan major upgrades to it. And frankly, if anybody was interested in this, they're welcome to transplant the thing, because again, I don't have ongoing projects. I'm planning on retiring in another 2 years and sort of slowly ramping things down. So as long as this continues to run, it doesn't take a lot of our time. We keep it going, and occasionally we do get inquiries, so I know a few people look at it. So I'm happy to take any questions.
Thank you for that, Dennis. Okay, any questions? I've got a few, but I want to make sure we give other people an opportunity.
I've got some too, but I don't want to be annoying, so ask your professional questions first. I'm just a user.
No, go ahead, Glenn.
Well, on the VIC, it would be nice if it was more clear on the website what depth you're looking at. It might be in there somewhere, but I had a hard time finding it. So it's interesting here that it is 1 meter. But the main thing I'm looking for is the East version map is good. It's got county lines and it's fairly high resolution. It would be nice to have the 1 month, 2 month, and 3 month forecast with that same kind of a map, because their maps are a little lower resolution and there's no county lines.
Yeah, I have to say the county lines and all of the stuff with the maps and so on probably go back 15 years or so. At one time we were running forecasts, and I think we were doing ESP, which of course is just resampling, right? I mean, that's a method the Weather Service has used for seasonal forecasts going back to the 1970s. We have done various research projects using NMME and so on, but none of that is actively in there. And again, it goes back to the point that I don't have, people working. I have a graduate student who is supposed to go look at this periodically and see if something choked, which occasionally it does, and you get something that doesn't make any sense. There are other products out there. I mean, I think this is the kind of thing the community would have to decide this is something we really want and need. At this point, I'd be very happy to look over somebody's shoulder if somebody wanted to take this, modify it, and so on. It's yours for the taking.
Well, the other thing is it possible to show the results as absolute amount anomaly, inches of water or millimeters of water, instead of the percentiles? I'm more interested in the amount of water above or below, the long-term average. And is it, third question and last question, I guess, is you're comparing to the 1916 to 2004 average. Is it possible to compare to a more recent 30-year average?
Yeah, well, all of that's possible. It's just a matter of some minor coding. But that's the way, it's the way it's set up at present. I'm sorry, what was the first part of the question?
Show the
absolute
results
amount
as absolute anomaly, not the percentile. I really don't care about whether it's 20th or 10th percentile. I just want to know how much water we're above or below normal compared to a recent norm.
The problem with that with models is every model has its own climatology. So when you say absolute amount, that sounds like something that's obvious. In the modeling world, it's really not, because the soil moisture dynamics are set up differently in the models. So if you look at the absolute amounts for different models, they'll look much, much different just because of the assumptions they make and so on. It's the percentiles that look closer. So the thing The thing to do would be to take the percentile for the given model and then go look at what the corresponding absolute amount is if you want it. But you have to be very careful how you interpret that. I mean, we've gone way back in the modeling world with this, where people tried to do exactly what you suggest and realize stuff's just all over the map. And it's because of the way the models are wired. They do give with the percentile something that looks more similar. I know that's not a very good answer, but you got to be very careful with what you take out of a model. Now, that said, the obvious question is, do the absolute amounts make any sense at all? And way back when, in a paper in 2002, there were comparisons done, and at the time, about the only place you could get relatively long-term soil moisture data was Illinois, and there's some comparisons with Illinois, which look plausibly realistic, let's put it that way. And I can refer you to that paper if you're interested.
Okay, well, I appreciate that. It just seems like when you run that model to get a percentile, at some point of the process, you had to have an amount relative to the quote norm. So instead of just turning it into a percentile, I'd rather just have you stop there and show me how far above or below the norm you're looking at.
But of course, I'm sure you will understand, if you look at Drought Monitor, they give you like D0, D1, and so on, right? Drought categories. And there is a mapping for that, which we don't show here, but it's easy enough to do. And this is in a paper. I'm trying to remember whose paper it was at the Drought, the Lincoln group, which basically just converts from percentiles to D0 and so on. And I think we're even using colors on those maps that are consistent with what the Drought Monitor uses. So you got the same problem with the Drought Monitor, right? Because they tell you that it's a D3 drought, but if you want absolute amounts, how do you get to there?
Yeah, I don't even use Drought Monitor because it's far too slow for my purposes. I mean, our plants would be dead if we went by that.
Well, the slow part, I think we solved because we get it to you in a day. But the absolute amount part, no, we don't.
No, I mean, it's slow in terms of the Drought Monitor. This is off topic, but the Drought Monitor itself is not set up to, I use the crop moisture index instead of the Drought Monitor because the Drought Monitor is just far too slow of a model in terms of responding to conditions. That's why I like it. It's more real time.
Okay. So the other thing, though, is that you have to ask when you're looking at actual conditions. So what we're showing is total column soil moisture. The models have different layers in them. Vic has 3. That's sort of fairly typical. NOAA has 4 and so on. The top layer in Vic is typically about 10 centimeters. And the reason I don't tell you exactly is because it's not the same everywhere. And that's true of most of these models. But obviously that top layer responds a lot more quickly than the total column does. And we've done, and there may even be in there in the distant past maps where we've mapped the different layers as well as the total column. The problem is it almost responds too quickly because, you know, you get one little rain shower and now the top model or the top layer is wet again. And it says the drought went away. And people already complain about, well, you know, the drought, there's this big argument in California. When did the 2013-16 drought actually ended? We said it ended quite a bit before the state did, but there's all this discussion about groundwater and so on. And groundwater isn't in the current form of any of these models. We've actually done work where NOAMP has a groundwater algorithm and looked at that. But then you get into that whole discussion of what is a drought.
Yeah, I like Vic, and one of the links on the site did lead me to papers that explained about the 3 layers and the depths and how it's all done, and I find that useful. The problem with USDM, for me anyway, is it's not just about plant accessibility to water. It also includes stream flow and reservoirs. It's just a much bigger, it's a battleship drought model, and I'm looking for the speedboat. But anyway,
well, actually,
I like Vic.
It isn't even a model, really. I mean, it's more of a concept, right? I mean, and this has been, you know, I'm sure you're well aware, there's been a discussion ongoing forever as to, you know, quantitative sort of reproducible drought estimates versus more subjective ones. And the plus side of more subjective is that there's things that the model doesn't really consider. The downside is that since it was people sitting around a table making the decision, you can't reproduce it.
So, yeah, sorry. Just want to make sure we have a chance if anyone else has a specifically back to your experimental water monitor. But yes, these are ongoing issues that we talk about at NIDIS.
Okay, I don't know if there are other questions.
Yeah, this is Marina. I don't know what you were going to ask. I just had a clarification. So you mentioned that the maps that are available for the continental U.S. are only available on the surface water monitor. Is that correct? That link that I put in the chat box?
I think so. So I used, before she retired, I worked pretty closely with Kinksy Mo at CPC. And some of this had been ported over to CPC. The status of that, I don't know, since Kinksy retired 2 or 3 years ago. There used to be a variation. There is a variation of some of this stuff with NLDAS because Vic is one of the models in NLDAS, different forcings and all the rest. I'm not sure exactly what is on their site these days.
Okay, that's helpful. Because you had mentioned, just again to clarify, that the surface water monitor with the continental U.S. maps, that is just the Vic model, is that correct?
No, it's the 4 models that I showed.
Oh, it is the 4. Okay.
They are all run off across conterminous US at this coarse 1/2 degree resolution.
Okay, thank you.
So just, well, I guess an observation, Dennis, what we're hearing from you, when we have heard that people do consult with this model to get insight into soil moisture status, but what we're hearing, or at least I'm hearing, is that if there's any interest in having this continue, it's going to be outside of your court. It's something the community needs to think about and develop some kind of plan for. Is that, am I hearing?
It's not going to last forever because the day I walk out the door, somebody's got to decide what to do about the computers, and the time will come when they get sent off to surplus. So it's not going to happen in the next 2 years. We'll certainly keep running it, but you know, it will go away at some point.
So then another question I have is on the 4 models, and if you can draw off any experience you have of which one you think sort of best serves, maybe in this case the Midwest, or that certain kind of groundwater levels, et cetera, any kind of insight you could share about how to sort of pick between these 3 or 4 or not pick because they all have their own role.
Well, you can get some hint of this from what we're doing at the West, which is a little bit more current, in that we're just running 2 models now over the entire West, and one of them is NOAA-MP, which is the National Water Model, which, you know, it certainly has some traction, and I think it's hydrologically credible. If I was sitting there and had a bunch of people and a bunch of money to pay them with and was going to go upgrade this thing, what I would probably do is I would yank NOAA, I would put NOAA-MP in there. And I might yank 1 or 2 of the other models. I would probably, you know, I would try to keep a suite of models because I think the multi-model part of it is worthwhile. We have in research mode run NOAA-MP across the conterminous US with the groundwater option on. What we do in the West is that we leave it off. It actually, somewhat surprisingly, doesn't make too much difference to total column soil moisture. Obviously, since it's got groundwater, if you look at the groundwater stuff alone, you get some perspectives. I think there's probably some value. There's probably some value in that. Most of the other models, none of them represent groundwater at all. They're basically just a soil slab.
Okay. One last question for you, just a reflection question. NIDIS and other researchers that we interact with are starting to think about how do we look at period of record and what's appropriate in a changing climate. And you had talked about how your model goes back to 1920, so that's quite a long period of record, again, giving a certain kind of normal. Any reflections on how or whether that should shift, again, with climate change?
Well, that's a similar question to the one of define drought and how many soil moisture layers and so on. There's certainly an argument, in fact, it's more than just an argument, that the climatology has shifted. So there is a plausible argument to be made to go make the history be relatively shorter and perhaps last 40 or 50 years. The history of including the 1930s is that about the time we started this, which was then NCDC, got all of the cooperative observer stations digitized. Prior to that, they'd only been from 1948 or halfway through 48 or something on. So being able to get the data back to the 30s and reconstruct the 30s drought was a pretty big deal. But now the question is, do you really want the 30s drought influencing your percentiles? I don't have a good answer to that. I wouldn't argue too hard against making the history be a more recent sort of post-70s. That is the period, certainly in the West, where most of the warming has occurred. I mean, you've got much different and cooler climate in the early part of the record for the West when you go back as far as the 1920s. It's easy enough to just go change the algorithm that computes the percentiles and not use the earlier part of the record.
Right. Okay. Well, last call for any questions or observations on this. Okay. Well, thanks very much, Dennis. Really appreciate your time and your presentation of this tool. And we'll be obviously monitoring how it evolves and perhaps involved with that.
Okay.
Now we'd like to turn to Dan McAvoy. On the agenda, we had said Justin Huntington would be joining, but he was unable to. So Dan has offered to pitch it here and provide an overall introduction to Climate Engine, then with a focus on the soil moisture parts.
All right, well, great. Thanks, Marina, for the introductions. And it was great to hear Dennis's talk to set the stage a bit. This is going to be a bit different in that I'm going to be presenting more on a tool to display and analyze data as opposed to presenting on a specific soil moisture product that we have developed. This is going to be about Climate Engine. And to be honest, up until recently, we haven't spent a ton of time on getting the best soil moisture products in Climate Engine. We'd focused a lot on the atmospheric drought monitoring variables, but we're moving towards getting better soil moisture products into Climate Engine, and so I wanted to cover a bit of that as well as the general drought monitoring within Climate Engine. Let's see here. So I do want to make the point clear that there is a Climate Engine team behind all this. I've participated in the sort of R&D and the sort of ideas around developing Climate Engine over the years. Justin Huntington's the main PI, along with John Abotsklou at the University of Merced, California. But the real credit goes to the software developers that I've listed out here that work really hard to develop this web application. So I put the link up top there. It's app.climateengine.org/climateengine. And so the basis for this tool, it is powered by Google Earth Engine on the back end. So it's a cloud computing platform on the back end. And so we have developed a point and click style front end to access all these data sets that are housed on Google Earth Engine. And so they have a whole catalog. Google hosts a whole catalog of weather and climate data sets. And so with some Python or JavaScript code in their Google Earth Engine code base, you can access any of those data sets and do whatever you want with them, but you have to know how to program. And so the idea was to develop this front end that hits the Google Earth engine on the back end and makes it easy to access and visualize all these data sets. And so we have gridded climate data, remote sensing data, and more recently some subseasonal climate forecasts. A lot of these products are daily and updated in near real time within a couple days of the most recent date. I'll be showing some CONUS examples, but a lot of these data sets also cover the entire globe, and we have both mapping and time series options. And this is an example showing the MODIS actual evapotranspiration product, the percentiles for last summer, and you can see the interface there on the left with the mapping and graphing options. And so the first thing, you go to Climate Engine and you ask, what data sets do you want to use? Well, there's a ton in here. We have the climate data sets listed there on the left. There's GridMet, PRISM, CFS reanalysis, Aero5, Meritu, the list goes on. Then we have the entire Landsat and MODIS archive. We have Sentinel and a few other remote sensing data products. And again, more recently, the downscaled CFS forecasts. And so, yeah, this is quite overwhelming, and it takes a while to fully digest what's in Climate Engine. We've done trainings specifically for certain groups on which products are most suited for their application, like rangeland monitoring or fire danger, that sort of thing, and drought monitoring. And so you got to figure out what's best for you. But I'm going to focus a bit, just cover a few on the drought indices, and then talk about the soil moisture products that we have. So number of the gridded data sets have the option to get drought indices, including the SPI, SPEI, the EDI, PDSI, and we also have the CPC based, the long-term and short-term blends using the GridMet data set. You can get a number of different time scales that we have preset, or you can create your own custom time scale if you want. This example here is showing the 3-month SPI from the PRISM monthly data set. And so this uses the distribution going all the way back to 1895. And so this is showing December through February 2022 SPI. And so it's updated monthly with this PRISM monthly data. And so again, you also have a time series option. So for drought indices, we only have time series currently. We're working on improving this, but currently with the GridMet data, and these are pentad. So every 5 days, the time series is updated. And this is just an example showing, I picked a grid point in Northeast Kansas, and it's a 30-day SPEI. And so it's updated every 5 days. And so this is going through the past year. And you see over the past year, there's been ups and downs, but this overall decline in the 30-day SPEI with some real low negative values at the beginning of this year. And so you can look at your map, zoom in, point and click on a point, and then make a graph of what you're looking at on the map over time. And so it's sort of this idea of place-based drought monitoring. And in terms of remote sensing, there are several products that are useful for drought monitoring and also have a pretty strong relation to soil moisture. The two that I would point out are from MODIS, the land surface temperature anomalies, and the actual evapotranspiration anomalies. What I'm showing here on the map is the land surface temperature anomaly, difference from average for last summer, and the reds are warmer than average and the blues are below. And this isn't air temperature, this is land surface temperature or skin temperature. And so this actually pairs really well with soil moisture. It can tell you a lot about the soil moisture information, as there's a pretty strong relationship between land surface temperature, evapotranspiration, and soil moisture. And so we see on this last summer map, we see the blues influenced from the monsoon and then the really strong hot and dry Pacific Northwest and California patterns there. We also have normalized difference vegetation index from MODIS and Landsat as well. So let's get into what we have available for soil moisture. As I mentioned, we're working to get some new ones in there right now, but these are what we currently have available. We have the FLDAS, which is the Famine Early Warning System Network, LDAS, and then the GLDAS. Oops, sorry for the typo there. That's the global LDAS system. Those are both monthly. And we also have the CFSR, the Climate Forecast System Reanalysis, which is a daily product. And then we're currently being developed, and there's a beta version available that I'll show, is the Climate Engine tool for the US CRN network. And this map here is showing from last summer the FLDAS soil moisture percentiles. And so you can compute the actual values, the anomalies, the percentiles. I chose to show the percentiles here. And you can see there was some correlation to that land surface temperature anomaly map I was showing on the previous slide with the soil moisture here from FLDAS. And this is showing the 10 centimeter depth. We do have several depth layers from each model available. And again, you can do some neat things with the time series tool. And so one option we have is this 2 variable time series where you can overlay, for example, soil moisture and precipitation, which I've done here. Basically, I pulled a point here. This is a grid point in Iowa, and I plotted April through September of 2012, the drought period there. And so the blue line is basically the surface, the 5 centimeter CFSR soil moisture. And then the green line is the precipitation trace. And so you can see the soil moisture and the response there to the precipitation and the very low values in the summer, and also the very low precipitation values. And so you can do this with whatever variables you'd like, temperature, wind speed, humidity, that sort of thing. Whatever comes out of these different models, you can do this 2 variable time series approach. I did want to spend a little bit of time on the CRN, the Climate Engine CRN tool that is currently getting close to having the first beta version being complete, but it is publicly available right now. You just swap the slash at the end with NOAA CRN, and of course these are the Climate Reference Network stations. These are sort of benchmark weather stations, monitoring stations that were put in place. Some of them, over 10 to 15 years of data to eventually have a long-term benchmark climate monitoring network. And so within Climate Engine, we have the stations and also the SWAMP, which is the gridded soil moisture product. We are still working on that gridded product. There have been some issues with the alignment of the grids and that sort of thing. So I'm going to focus and show some examples what you can do with the stations from CRN within Climate Engine. So I'm going to show some time series examples, and I pulled one. This is from Yosemite Village, the CRN there, the 10 centimeter soil moisture, and I decided to plot the last year's worth of data. And so the soil moisture, 10 centimeters, the blue trace, and then the precipitation there is the green trace. And you see a few things. We had that big atmospheric river in October, and you see the response of the near surface soil moisture there. One thing I noticed there, the precipitation timing and the magnitude does not seem correct. That should be aligned more closely to the soil moisture bump. And so you do have to be careful. This data is coming straight from the CRN database, and some of it might need QA/QC. The December traces look a bit more realistic for precipitation as well as soil moisture. And so you can also compare 2 different depths of soil moisture. And so this is, again, the same Yosemite site. And now I've overlaid the 5 centimeter depth with the 100 centimeter depth. And so you can see how these different soil levels are responding over time. And, another neat feature here is that you can compare the model data to the station data at a point. And so you can do some get a sense of how well these models are performing if you want to just quickly take a look at some of these traces. And you can get all this data and download it and do your own analysis if you would like. And so this again is the Yosemite CRN point for the past year with the 5 centimeter soil moisture, and CFSR also has a 5 centimeter soil moisture layer. And so as long as the data set time periods overlap, you can do this kind of plot where you can compare the modeled soil moisture versus the observations. And so this is for the past year. And overall for this particular case, CFSR does seem to be getting the overall seasonal pattern and the big wetting and drying events. Of course, there's some variation, but it is nice to be able to quickly take a look at how well these compare to models. And I chose another grid point at the Champaign, Illinois CRN again for the last year. And there's a bit more discrepancy, I would say, between the model and the station compared to what we saw at the Yosemite point. And then as you get to the end of that time series, it looks like the CRN might have had some missing data or something. There's looks like a bad trace there toward the end. But again, you can download all this data and run your own analysis if you want to dig into the weeds. And you can get the period of record for these. So this is going back to the Yosemite site, and I plotted up the period of record. I thought it said it went back to 2007, but for some reason this plotted starting in 2012. And you can see the big drought period in 2012 to 2015. According to this station, and this is now the 100, the deep soil moisture layer at 100 centimeters. And so you can see that it appeared at least the peaks were actually lower in that 2012 to 2015 drought than the last couple of years. And we see the big response this year in the deep layers from the atmospheric river and then the big December storms. But that essentially shut off and it's starting to level out again. And again, you can download the CSV of this and get all this data and do whatever you like with it. And one last thing, I just wanted to mention that we do have a Climate Engine API. It is still, the documentation is still being developed, but it is available. If you're interested, you would contact me or Justin Huntington to get a key and learn about where to find the documentation for that. I just wanted to show like one example of what you might be able to do with the Climate Engine API. So everything I just showed through the Climate Engine web application, you could take that API and access any of those data sets yourself. And so drought.gov is actually using the API to populate some of their current conditions pages. And so they're using the Climate Engine API, grabbing the most recent precipitation and temperature fields, and then doing their own mapping and displaying on the drought.gov webpage. And so if you were interested in the products on Climate Engine and want to do your own thing with displaying or putting it on your own website, the API would be a great option there. And again, if anyone's interested in that, we can talk offline on how to get someone started with that in the documentation. So what's next? I mentioned there are a lot of what I would think would be better soil moisture products that we could get into Climate Engine. Not sure if Justin has already talked with Dennis, but we were discussing possibly getting UCLA soil moisture products in Climate Engine. GRACE is another thing we've been thinking about. WL-DAS, that's specifically for the Western US. Or if there's other daily or weekly updated products. And so basically if Google Earth Engine agrees to upload a product to their cloud, then we can hit it with Climate Engine. Or if they don't want to do that, we can create a Google bucket and make our own basically image collection and still pull it into Climate Engine. So pretty much any of these data products we would be able to get actively into Climate Engine. And so yeah, there's a lot more on there. There is a landing page, climateengine.org. We have like examples and news and that sort of thing. There is a whole user manual, a very detailed, long user manual on how to use these different features. I didn't get into the subseasonal forecasts, but that's drawn quite a bit of interest. And again, a lot of these products are global. So we have Alaska for a lot of these products as well. This is just showing the ERA 5 recent 30-day temperature anomaly across the globe. I think that was all I had, and I'll leave some time for questions. So thank you.
Great. Thanks very much, Dan. I want to just start out with one quick question. We understand you guys are moving to a little different interface, not interface, but login procedure. Is that right? Would you want to mention that to folks?
Yes, and I think Justin would have a bit more information on this, but you do need, as far as I know now, you do need to create a user account now to access Climate Engine the first time you use it. I think once you create that login, it will cache into most systems, and you don't, like when I pull it up now, I rarely have to log in unless I'm on a different computer or something like that. But yeah, we're trying to track users and get a better handle on who's using Climate Engine. But it is still the same publicly available free tool.
Okay, yeah, great. Okay, any other questions for Dan?
Hi, Dan, this is Glenn Kaler again. So I have been all over Climate Engine the last few weeks. And I don't know who else is on this call, but if you don't know about Climate Engine, it's really great. It's an awesome tool. So thanks for that. I was not aware of the soil moisture, the things, the NOAA CRN. I don't know if they're linked from the regular Climate Engine site or not. I just got there from that link you posted. So I guess that's now publicly available, right?
It is, and yeah, to be honest, I wasn't that up to date with it until I spoke with Justin a couple days ago, Justin Huntington. But yeah, it is a separate link. You have to type in that specific link. So I don't think there's an access link through the main Climate Engine page. I think it's just starting to be released a bit more publicly because it was in development for a while, but it's all there and it's all public.
That's great. So just two questions. So like if I pick 100 centimeter depth, the values are all shown as fractions. So there's no, again, millimeters or inches, but I can do that easy enough by just multiplying the fraction times the depth, right? To get the inches.
That is a good question, and I can follow up with you on that. I'm honestly not sure if it's that straightforward of a conversion or not, but I can find out because I know who's making those calculations.
Right, or Dan, that's the kind of thing that we could direct Glenn to the CRN folks, right? I mean, they
Right, yeah, so that's a good point. I don't know if Climate Engine's doing those calculations or if that's what CRN is directly posting.
Well, yes, I don't know either, obviously, but I do know that the CRN folks and Mike Pilecki, for example, at NCEI would have a good handle on just how those numbers might be manipulated and changed. So I would take that off your plate. You guys have plenty of other things you've got to do.
Thank you.
So if you guys wanted to take over Vic, as was mentioned just previously, that would be a great one to do. And the only problem I have with what I'm seeing on the CRN site is if I look at Climate Toolbox, which is very similar to Engine, their update lag is less than Climate Engine by several days. I know you can only get what you can get, but it seems like Toolbox is getting stuff a little more recent. And I wonder if these soil moisture measures, they're about a week old. The ones I looked at, the most recent data is about a week old. Anything you can get that more up to date would be great.
Yeah, and we've talked about this in the past, and this comes down to the Google side of it, the Google Earth Engine, since they're the ones actually hosting most of these data sets, and it's all about when they run their updates. And for example, the GridMet is what you mostly see on the Climate Toolbox, and that's oftentimes about a day or two ahead of what's on Climate Engine. And I've brought this up and others have brought this up. So we are working to try to reduce that latency.
Any other questions?
Oh, I'm sorry. I was just going to say, in terms of the UCLA data, we could pretty easily grab that data and have it available in Climate Engine. In terms of running the models, that's another story. We wouldn't be able to do that on the Climate Engine side.
So Dan, this is Dennis, and apologies for, I don't know how you raise your hand in this system, but you may, and you in the broad sense, there's been discussions with John Abbotsglou. He has access to some of that. And this was like about 6 months ago. I don't remember the details, but those discussions are already underway. Some of it, and it may just be the West, I'm not 100% certain. But I think he has some of it and pulls it off. And this presentation and your presentation motivates me to make contact again and broaden the discussion perhaps a little bit. Because we're certainly happy to have you guys have it.
That's great. Thanks, Dennis. I think, yeah, myself or Justin and or John will probably be following up with you here shortly.
Okay, other questions or comments? I'd actually like to invite those of you active climatologists in the Midwest to reflect on or share with Dan thoughts on other tools they might include here. If you can think of the ones that we've looked at through the series or otherwise that you think would be served by this kind of nice space. Okay, we have a quiet crew, but one of the things I wanted to ask you, Dan, actually, you mentioned it, we discussed this yesterday, but just to share with the group, this idea that you're bringing, at this point, the point data from CRN, but there is also the option to bring in some of the other Mesonet point data, to enrich that particular slice of information.
Yeah, certainly. And I think, after seeing what we can do with CRN, if there's other networks, other Mesonets, others from the soil moisture monitoring, the national network, that would make sense to overlap, or I guess we'd have to figure out if it would all be on the same interface where you basically select your observation network. That could be one option, as opposed to having a new link for each network. But certainly, yeah, there's options to include other monitoring networks in there as well.
Right, enrich the point data. Yeah, at the very least, thinking about the national networks.
Yeah, and so I think we were asked by the CRN group to work on this, and that's how this observation thing got started. There's another project in the Navajo Nation where we host some of their precipitation observation sites, and so yeah, certainly we could include other OBS networks.
Great. Okay. Any other questions? Giving everybody a moment. All right. Well, Dan, thank you very much for your time. I think Dennis has dropped off, but really appreciate this introduction to Climate Engine. I'm not sure how familiar folks on the call were, but this has really been, for me, actually, a very good introduction. So I do appreciate it, and I think others do as well. So,
hey, Dan, any chance of a forecast?
For having me.
Go ahead, Glenn. What?
Any chance of forecasting soil moisture?
So that's a good question. The product we have on there right now is downscaled using GridMet, and we don't include, well, there's no GridMet soil moisture, but it is something to think about, and I know there would be interest in it. So it is possible, but we don't have it available right now.
Okay. Well, again, thanks very much, Dan. Molly, I think we're at the point of saying goodbye to everyone for the moment.
Yeah, I think that's true, and we'll follow up at some point. I've been sharing the notes as we've gone along, and I will do the same along with the recording for this. But moving forward, we will likely be in touch with a larger group, maybe if there are next steps that come from this in terms of, more of a look into certain products for the region, more validation, that sort of thing. So we'll definitely be in touch as those things advance.
Yeah, and we also are going to follow up as we've been going along, sending you that spreadsheet with a little bit of detailed data about the different tools. We weren't able to get it this time for various reasons for these two tools, but we will follow up on that and then give you the full package so that you can see the whole suite that we've reviewed and again, the details about them. And then as mentioned, we are orienting towards coming back together and thinking about next steps for this process and how we can continue this process and the effort so that you all get the tools you need to help you with your decision making. So stay tuned on that.
All right, well, thank you, everyone. Have a nice day.
Bye.
So.